Hey there, in this video we're going to talk about how we can find the square root of a negative number. This is one of my favorite topics because it really shows the power of human creativity in the development of useful mathematics. So if you've dealt with square roots before, then you've seen that every positive number actually has two possible square roots. If we want to find the solutions to this equation, x squared equals 4, there are two possible answers. X could equal positive 2 or negative 2, because a negative number times a negative number will still equal a positive number. Well, what happens if we try to solve an equation like x squared equals negative 4? Is there a number or possibly multiple numbers that could make this equation true? Now, your first instinct might be to try, what if we try like negative 2? But the issue is if we multiply a negative times a negative, we still get back to a positive answer. We could try multiplying a negative times a positive, but then that goes counter to the definition of a square root, because a number squared has to be the same number times itself, not two different numbers. So if you're feeling stuck, that actually makes sense. The issue is that with the numbers that we're used to dealing with, positive and negative numbers, there is no solution to this equation. But mathematicians don't want to just get stuck and say, well, there's no possible answer. If possible, we want to dig deeper and see if there is a way that we can find a solution to this. So a few hundred years ago, mathematicians had a pretty clever idea, which was, it doesn't seem like there's any number that can make this equation true. But why don't we just invent a new type of number that will allow us to solve this equation? And the insight that mathematicians came up with is, what if we create a new type of number that is defined so that when we square it, the answer is a negative number? And this new number that mathematicians came up with is the number called I, which stands for the imaginary unit. So all of a sudden, that opens up a whole new world of possibilities. Using this imaginary unit, we are now able to take the square root of a negative number. The definition of I is that it is the number whose square is equal to negative 1. So a similar statement would be that the square root of negative 1 is equal to I, just like the square root of positive 1 is equal to 1. So think of I like it is the imaginary equivalent of 1. So the way that we can use this in solving equations is anytime we need to find the square root of a negative number, we just have to remember to also include the I, meaning that our answer is what we call an imaginary number. So just like every positive number has two possible square roots, a positive and negative answer, any negative number also has two possible square roots, which are just the imaginary equivalent of what we would get if we took the positive square root. So the square roots of 4 are positive and negative 2, and the square roots of negative 4 are positive and negative imaginary 2, or positive and negative 2i. Or if we wanted to take the square root of 25, the square roots of positive 25 are positive and negative 5. And now we do have a way to find the square root of negative 25. We would say that these are positive or negative 5i. And we can also use I to find square roots of numbers that are not perfect squares. Like if we want to find the square root of 10, there is no integer that we can multiply times itself to get 10, but we would just write this as x equals the positive and negative principal root of 10. So this square root of 10, that just means some number that if we multiply it times itself equals 10, and you could use a calculator to calculate what that number is as a decimal. So we could also find the square root of negative 10. It would be plus or minus square root of 10i. So this is pretty weird, right? I mean, I totally understand if at this point you're thinking, well, wait, this just sounds like a bunch of nonsense. You can't just make up new kinds of numbers. Why are we even learning about numbers that are imaginary if they're not real? But this is what I love about this topic, is that it really caused me to broaden my understanding about what it even means to be a number. So you might say, well, imaginary numbers are just made up, but I would argue that really all numbers are, in a sense, made up. Math is a tool that humans have created to make sense of the world around us. So numbers are just concepts that exist within the human mind, and the history of mathematics is a rich history of humans always inventing new types of numbers. So the earliest numbers that people dealt with were numbers that we used to count things, what are called the natural numbers. Numbers like 0, 1, 2, 3, and so on. These numbers on the number line. But eventually, humans also realized that there were certain problems that could not be solved just with natural numbers alone. Like, what if I take a square that has each side equal to 1 unit, and I want to divide this square into 2 pieces? Well, what number represents the length of half of this square? We can't use a natural number or a whole number. We need to create a new type of number, a fraction, 1/2. So then we added in the rational numbers, inventing in new types of numbers that we could use to solve problems. But that wasn't enough. There were some other types of numbers that humans needed to create to continue to answer questions about the world around them. So what if we take a square where each side has length 1, and we want to measure the length of the diagonal of that square? That diagonal cannot be represented using a fraction because we would need to use the Pythagorean theorem to calculate its length, and we end up with a number that is a square root, the square root of 2. So that gave us a new type of number, numbers that could not be represented using whole numbers or fractions, what are called irrational numbers, like the square root of 2, or another irrational number you're probably very familiar with. To measure the circumference of a circle, the distance around the outside of a circle, we can use the number pi, which is another example of an irrational number. And there are some more types of numbers that humans had to invent to make sense of the world. So as civilizations became more advanced and money became a concept that most societies were using, we extended this number line out to include not just positive numbers, but negative numbers as well. Like if I have $5, but I owe someone $8, well, we could say that essentially the value of what I have is like negative $3. So if we try to solve this equation, 5 minus 8 equals what? Well, for much of human history, there was no number that we would say answered that problem, but we just invented a type of number called negative numbers that allowed us to make sense of that. So all of these groups of numbers together, the integers, the rational numbers, the irrational numbers, the negative numbers, that group of numbers that we know of as existing on the number line, those have all been given the name the real numbers. So when it came time to create a new type of number a few hundred years ago that would allow us to find square roots of negative numbers, we called those imaginary numbers to contrast them with the real numbers. But I think that title is sort of misleading, and just keep in mind that imaginary is more of a historical term than a mathematical one. Even though we call them imaginary numbers, that doesn't mean that they're fake. I mean, it's true they might be, in a sense, made up, but all numbers are just made up by humans to solve problems. And if a number is useful in our brains, that's really what makes that number powerful as a concept. And indeed, history has proven us right that imaginary numbers are very useful in a variety of fields like electronics, physics, computer science, and video game graphics.